Every time you connect to Wi-Fi, your device gets an IP address instantly. No setup, no typing, it just works. But have you ever wondered who is assigning that IP address and what would happen if that system suddenly stopped working? No internet, no communication, complete network chaos. Behind this simple process is something powerful, DHCP, a protocol silently managing every device on your network. In this video, we will break down how DHCP actually works, how your device gets its identity, and even how you can configure your own DHCP server like a pro. By the end of this video, you won't just use DHCP, you will understand it. Suppose you boot up your laptop and connect it to the internet. Now, if you try to visit google.com, you won't be able to access it until your device has an IP address. So to make the internet accessible, an IP address needs to be assigned to your device by the network administrator. And this can be done either manually or automatically. Let's say we have a network of 3 laptops. The network administrator can go to each device and manually configure the TCP IP settings on every host. But if the number of hosts increases to 300, then it becomes practically very difficult to configure each device manually. So instead of configuring 300 hosts one by one, the administrator set up one special host that runs a service to lease IP address to all connected devices. This special host is called a DHCP server. Now you might be thinking, in our home, we don't have a DHCP server, but IP addresses are still assigned automatically, right? That's because your home router already has a built-in DHCP server. So, whenever your device with automatic IP settings enabled connect to your network, it runs the DHCP protocol. As a result, the DHCP servers assigned an IP address to your laptop, and now you can access google.com without any issues. Now that we know what DHCP does, let's understand what it actually is. DHCP stands for Dynamic Host Configuration Protocol. In simple terms, it's a network management tool that automatically assigns IP addresses, along with other important settings like subnet mask, default gateway, and DNS server. But DHCP isn't just one thing. It's made up of several components. Let's break them down one by one. First, we have the DHCP server. This is usually your router or a dedicated server. It manages everything, keeps a pool of IP addresses, and assigns them to devices. Next is the DHCP client. This is any device you use, your laptop, phone, printer, even IoT devices. Basically anything that connect to the network and request an IP addresses. Now sometimes, devices and servers are on different networks and they can't communicate directly. That's where the DHCP relay comes in. It acts like a middleman, forwarding requests between the client and the server. Then we have the IP address pool. This is simply a range of IP addresses that the DHCP server can assign to devices. But here's the important part. These IP addresses are not given forever. They are given for a limited time called a lease. After that, the device has to renew it to keep using the same IP. Along with the IP addresses, DHCP also provides extra configuration. These are called DHCP options. This includes things like DNS servers, domain names, and other network settings. Two very important options are the default gateway. This is what allows your devices to communicate outside your local network, basically access the internet, and DNS servers. These help convert domain names like google.com into an IP addresses. So all of this happens automatically in the background within seconds. And that's what makes DHCP so powerful. After understanding DHCP, let's now see how it actually operates at the application layer of the TCP IP model. DHCP uses UDP port 67 for the server and port 68 for the client to automatically assign network configuration. This happens through a client-server communication process called DORA. DORA? Don't worry, I'm not talking about the DORA the Explorer. I'm talking about the DORA process used by DHCP. So let's break it down step by step. First, the client sends a message to check whether any DHCP server is available on the network. This is called the DHCP discover message. Next, the DHCP server replies with an offer. This includes an available IP address along with the configuration options like subnet mask, default gateway, DNS, and lease time. This is called the DHCP offer message. Then the client selects one of the offers and confirms it. It requests the chosen DHCP server to assign that IP address officially. This is known as DHCP request message. Finally, the DHCP server sends a confirmation message. This is called the DHCP acknowledgement message. This message officially assigns the IP address to the client and provides all the required network configuration parameters. And just like that, within a few seconds, your device is ready to communicate on the network. Now let's understand how to configure a DHCP server in Cisco Packet Tracer. First of all, create a simple topology. Click on End Devices at the bottom left panel, then choose a server. You can also change the server name if you want. Now click on Network Devices, go to Switches, select a switch and place it in the workplace. Then again go to End Devices and place 2 PCs and 2 laptops. Now let's connect all the devices to the switch. Click on the lightning icon and connect each device. You can also click on fast forward time to make the connections faster. Now, let's configure the DHCP server. Click on the server, go to the desktop tab and then click on IP configuration. Enter the IP address 10.0.0.1 and the subnet mask 255.0.0.0. Go to Services, click on DHCP. Enter the default gateway is 10.0.0.1, which is the IP address of the server. Now you can see the start IP address range is 10.0.0.0. You can also see the maximum number of users, which is 512. You can change the number of users based on your requirement. Now save this configuration and turn on the DHCP service. So now our server is configured with the DHCP services. Next, go to PC0, open the desktop, click on IP configuration and select DHCP. Now you can see the IP addresses is 10.0.0.2 and subnet mask is 255.0.0.0 and default gateway is 10.0.0.1. So this IP address is automatically assigned by the DHCP server. Now let's check the IP addresses of the remaining devices. Finally, let's test the connectivity. First, check between PC0 and PC1. Click on PC0, go to command prompt and type ping 10.0.0.2. Now you can see the response, which means PC0 and PC1 are successfully connected. Now let's check connectivity between the laptops. Take a message where laptop 0 is the source and laptop 1 is the destination. Now you can see the packet is successfully sent from laptop 0 to laptop 1. So that's how DHCP works. From assigning IP addresses automatically to managing complete network configuration using the DORA process. Now you don't just use Wi-Fi every day, you actually understand what's happening behind it. If you enjoyed this video, you should definitely check out my TCP IP model playlist, where I explain each layer in a simple practical way, from how data moves to how network actually communicates. And if you are curious about how data travels on the internet, I have already made a video on how email works, where I break down what really happens when you click send in Gmail, from your devices all the way to the receiver's inbox. Both of these videos will help you connect the dots and build a strong networking foundation. So make sure to check them out And if this video helped you, don't forget to like, share and subscribe for more networking content. See you in the next one.